Hello everyone, welcome to Jee Mains 2011 Physics Solutions. The transverse displacement yx comma t of a wave on a string is given by yx comma t equal to e power minus of ax square plus bt square plus 2 root ab xt. This represents, let us see the given equation, yx comma t equal to e power minus of ax square plus bt square plus 2 root ab xt, which can be written in the form of e power minus of root ax plus root bt whole square by applying the formula a plus b whole square. Now this is in the standard form of a wave equation, that is e power minus of kx plus omega t whole square, where k is propagation constant and omega is angular frequency. Now you can see the power of e kx plus omega t. The plus indicates that the wave is traveling along a negative x direction, and from the standard equation the speed of the wave is given v equal to omega by k, that is root of b by a. A screw gauge gives the following reading when used to measure the diameter of a wire. The main scale reading is 0 mm, circular scale reading is 52 division. 1 millimeter of main scale corresponds to 100 divisions on the circular scale. The diameter of the wire from the above data is. The reading of screw gauge is given by main scale reading plus circular scale reading into least count plus or minus 0 error. As from the data given, you can see there is no 0 error mentioned in the question. Coming to the other values, the main scale reading is 0 mm, circular scale reading is 52 divisions. Now coming to the least count, it is 1 main scale reading by number of divisions on the circular scale, that comes out to be 1 by 100 millimeter. Now the diameter of the wire is MSR plus CSR into LC plus or minus 0 error, that is 0 plus 52 by 100, that is 0.52 millimeter, which is also equal to 0.052 centimeter. A mass m hangs with the help of a string wrapped around a pulley on a frictionless bearing. The pulley has mass small m and radius capital R. Assuming the pulley to be perfect uniform circular disc, the acceleration of the mass m, if the string does not slip on the pulley, is. As we can see from the diagram, for the block it is mg minus t equal to ma. For the pulley it is tau equal to I alpha. Torque is given by force into perpendicular distance. The force acting on the pulley is nothing but tension in the string. Perpendicular distance is radius of the pulley, so T into R equal to I alpha. From there it is TR equal to mr square by 2 alpha, because the pulley is taken to be a circular disc. From there we get T equal to ma by 2. Now solving the above two equations, we get A equal to 2 by 3g. Work done in increasing the size of a soap bubble from radius 3 cm to 5 cm is nearly, given the surface tension of soap solution, 0.03 Newton per meter. Work done by force due to surface tension is given by W equal to T into 2 times delta A. We need to write 2 times here because it is a soap bubble. It has a surface of contact both inside as well as outside. The increase in surface area delta A equal to A2 minus A1, that is 4 pi r square minus 4 pi small r square. Upon simplification it comes out to be 64 pi into 10 power minus 4 meter square. Now coming to the work done, surface tension into 2 times increase in surface area, we get it to be 0.384 pi into 10 power minus 4 joule, which is approximately 0.4 pi millijoule. A thin horizontal circular disc is rotating about a vertical axis passing through its center. An insect is at rest at a point near the rim of the disc. The insect now moves along the diameter of the disc to reach its other end. During the journey of the insect, the angular speed of the disc will. During the journey of the insect on the disc, there is no external force or torque acting on the system, so the angular momentum of the system is conserved. We can write I1 omega 1 equal to I2 omega 2. As the insect is initially on the rim and it is moving along the diameter, the moment of inertia of the system slowly decreases, becomes minimum when the insect is at the center of the disc, and then again increases to reach maximum value when the insect reaches the other end of the diameter. So there is a decrease and increase of moment of inertia. Since moment of inertia is inversely related to angular velocity, the angular velocity first increases and then decreases. Two particles are executing SHM of same amplitude A and frequency omega along x-axis. Their mean position is separated by a distance x0, which is greater than the amplitude. If the maximum separation between them is x0 plus A, the phase difference between their motion is. See the diagram carefully. The first particle is moving along PQ and the second particle is moving along P dash Q dash. The separation between the mean positions is x0 and the maximum separation is given to be x0 plus A. For maximum separation between the two particles, the first particle should be at the mean position and the second particle should be at the positive extreme position. If this is the case, the time difference between the two particles is 1/4 of the time period, because a particle takes t by 4 seconds for going from mean position to extreme position. From there, we can write the relation between phase difference and path difference. Phase difference delta phi equal to delta t by t into 2 pi. From there, it is equal to pi by 2. Two bodies of mass m and 4m are placed at a distance small r. The gravitational potential at a point on the line joining them, where the gravitational field is 0, is. The point on the line joining the two particles corresponding to 0 gravitational field intensity is known as null point. Let us find the null point first. Since the resultant gravitational field is 0, we can write the gravitational field due to first particle is cancelled by the field due to second particle. So it is gm by x square equal to g into 4m by r minus x whole square. That gives us x equal to r by 3. That means the null point is at a distance of r by 3 from the smaller mass. Now coming to the gravitational potential, it is minus gm by r. Since there are two particles here and the gravitational potential is a scalar quantity, we can write the total gravitational potential as Vg equal to minus gm by x plus g into 4m by r minus x. Upon substituting the given values, we get the total gravitational potential to be minus 9 gm by small r. Two identical charged spheres suspended from a common point by two massless strings of length L each initially are at a distance d, which is very much less than the length. The charge on spheres begins to leak from both of them at a constant rate. As a result, the charged particles approach each other with a velocity v. Then as a function of distance x between them, let us consider the equilibrium of particles at a separation of x between the two spheres. We can write from the diagram t cos theta equal to gravitational force and t sin theta equal to electrical force. Take the ratio, we get tan theta equal to F electrical by F gravitational. That is tan theta equal to kq square by x square and the gravitational force is mg. From there, write the value of tan theta, that is opposite side by adjacent side. Here, since we are using small angle approximation, we can replace tan theta with sin theta. That becomes opposite side by hypotenuse. That is x by 2 into L equal to kq square by mg into x square. Upon cross multiplication, we have x cube equal to 2kL by mg times q square. Differentiate the above equation with respect to time. 3 by 2 into x power 3 by 2 minus 1 dx by dt equal to some constant a times dq by dt. It is given that dq by dt is constant and dx by dt is speed of the particle. From there we get v equal to 2a by 3 x power minus 1 by 2, from which we can write v speed of the particle is proportional to x power minus 1 by 2. A boat is moving due east in a region where Earth's magnetic field is 5 into 10 power minus 5 Newton per ampere meter, due north and horizontal. The boat carries a vertical aerial 2 meter long. If the speed of the boat is 1.5 meter per second, the magnitude of the induced EMF in the wire of the aerial is. Aerial is nothing but a vertical antenna made up of some metal. Now here the aerial will be cutting the horizontal component of Earth's magnetic field. So it is a problem based on motional EMF. The EMF is given by E equal to BLV sin theta, where theta is the angle between the magnetic field and this velocity vector. In this case it is 90. So it is E equal to BLV. Upon substituting the given data, we obtain it as 0.15 millivolt. An object moving with a speed of 6.25 meter per second is decelerated at a rate given by dv by dt equal to minus 2.5 root v, where v is the instantaneous speed of the particle. Now the time taken by the object to come to rest is, initial speed of the particle is 6.25 meter per second. Now deceleration of the object equal to dv by dt, that is minus 2.5 root v. Upon rearranging the terms, we get 1 by root v dv equal to minus 2.5 dt. Now it is v power minus 1 by 2 dv equal to minus 2.5 dt. Now apply integration on both sides. Integral v initial to v final, v power minus 1 by 2 dv equal to integral 0 to t minus 2.5 dt. Upon carrying out integration and substituting the limits, we have t equal to 2 seconds where the object comes to rest. A fully charged capacitor C with initial charge capital Q is connected to a coil of self-inductance L at t equal to 0. The time at which the energy is stored equally between electric and magnetic fields is. The electric field of the capacitor stores energy in the form of electrostatic potential energy, and the magnetic field of the inductor stores the energy in the form of electromagnetic potential energy. Since initially the capacitor is fully charged, it will be storing the entire energy given by the formula Q square by 2C. Now as the energy stored is equally in between capacitor and inductor, so the energy stored in the capacitor should be half of the initial value. So the final energy stored in the capacitor is half of the initial energy, that is half of Q square by 2C. From there we get the relation between small q and capital Q. Small q equal to capital Q by root 2. Now as the charge oscillates between inductor and capacitor in simple harmonic fashion, we can write small q equal to capital Q times sine omega t. Omega is angular frequency, which can be written as 2 pi by t, where t is the time period of oscillation. Now substituting the value of small q in terms of capital Q, we get q by root t equal to q times sine 2 pi by t into small t. Upon simplification, we get small t equal to t by 8, which is pi by 4 times root LC. Here we get root LC because the time period of oscillation of LC oscillator is 2 pi root LC. Let the xz plane be the boundary between two transparent media. Medium 1 in z greater than or equal to 0 has a refractive index of root 2, and medium 2 z less than 0 has a refractive index of root 3. A ray of light in medium 1 given by the vector a bar equal to 6 root 3 I plus 8 root 3 j minus 10 k is incident on the plane of separation. The angle of refraction in medium 2 is. As xz plane is the boundary between the two transparent media, the normal should be along z-axis, that is represented by k cap. Now coming to the angle of incidence, you can have cos I equal to a bar dot k cap by a, that is the definition of dot product of two vectors. So from there we get I equal to 60 degrees. Now applying Snell's law, mu1 sin I equal to mu2 sin r. Mu1 is root 2, mu2 is root 3. So root 2 sin 60 equal to root 3 sin r. From there we get sin r equal to 1 by root 2. That gives us angle of refraction to be 45 degrees. A current I flows in an infinitely long wire with a cross section in the form of a semicircular ring of radius capital R. The magnitude of magnetic induction along its axis is. The cross section of the conductor, that is a semicircle of radius capital R, is shown in the figure. As current is flowing through the conductor, we have to calculate the magnetic field created by this conductor at the axis of the conductor. Now consider a small portion of the conductor of length dl which is subtending an angle d theta at the origin. Now the current carried by this small portion will create a magnetic field dB at the center of the conductor. The magnetic field due to the small portion of the conductor dB equal to mu naught by 2 pi di by r, that is mu naught by 2 pi r. Di can be written as I by pi r into dl. That is because the total current carried by the conductor is capital I and the circumference of the semicircle is pi r. So it is I by pi r into dl is the current carried by the small portion of the conductor. From there I can write dl equal to r times d theta, that is the length of the arc equal to radius times the angle subtended by the arc. So finally it is dB equal to mu naught I by 2 pi square r d theta. This magnetic field acts along the line as shown in the figure, which can be resolved into two components, dB cos theta along the diameter and dB sin theta perpendicular to the diameter. dB cos theta components will be cancelling each other because for every dl we take on one side of the diameter, there will be a dl on the other side of the diameter. So dB cos theta components are cancelled out, only dB sin theta components are left. So the total magnetic field is obtained by integrating the dB sin theta components. So B equal to 0 to pi integral dB sin theta, that is 0 to pi integral mu naught I by 2 pi square r sin theta d theta. Upon integration we get the answer out to be mu naught I by pi square r. Here I suggest the students to pause the video for some time and go through the integration process carefully. A thermally insulated vessel contains an ideal gas of molecular mass capital M and a ratio of specific heats gamma. It is moving with a speed v and suddenly brought to rest. Assuming no heat loss to the surroundings, its temperature will increase by. Here we can apply work energy theorem W net equal to delta K, that is K final minus K initial. As the cylinder is stopped, so final kinetic energy is 0, initial kinetic energy is half mv square. So W net equal to minus half mv square. As no heat is lost to the surroundings, it can be taken as adiabatic process. The increase in internal energy can be written as du equal to ncv dt, that is number of moles is mass by gram molecular mass, Cv is R by gamma minus 1 and dt. Now we shall apply first law of thermodynamics, dq equal to du plus dw, that is 0 equal to du plus dw. The increase in internal energy du equal to minus dw, that is m by m R by gamma minus 1 dt equal to half mv square. From there we get dt equal to gamma minus 1 mv square by 2r Kelvin. A mass capital M attached to the horizontal spring executes SHM with an amplitude A1. When the mass M passes through the mean position, a smaller mass small m is placed over it and both of them move together with an amplitude A2. The ratio A1 by A2 is. Initial mechanical energy of the particle is E1 equal to half m omega square A1 square, that is the total mechanical energy of a simple harmonic oscillator. The final mechanical energy of the system is E2 equal to half of m plus m omega square A2 square. As there is no external force acting on the system, we can apply law of conservation of mechanical energy here, that is the total mechanical energy of the system remains constant. That is E1 equal to E2 half m omega square A1 square equal to half of m plus m omega square A2 square. From there we get the ratio A1 by A2 equal to m plus m by m whole power 1 by 2. Water is flowing out continuously from a tap having an internal diameter 8 into 10 power minus 3 meter. The velocity of water as it leaves the tap is 0.4 meter per second. The diameter of water stream at a distance 2 into 10 power minus 1 meter below the tap is close to. Initial velocity of water is 0.4 meter per second. We can find the final velocity of the water by applying the formula v square minus u square equal to 2as. That is v equal to 2.04 meter per second. The area of cross section of the pipe is pi d square by 4, that comes out to be 16 pi into 10 power minus 6 meter square. We are asked to calculate area of cross section below 2 into 10 power minus 1 meter from the tap. We can apply equation of continuity A1 V1 equal to A2 V2. From there, upon simplification, we get the area to be 3.14 pi into 10 power minus 6 meter square and the diameter to be 3.6 into 10 power minus 3 meter. Statement 1. Skywave signals are used for long distance radio communication. These signals are in general less stable than ground wave signals. Statement 2. The state of ionosphere varies from hour to hour, day to day and season to season. Let us see statement 2 first. Ionosphere is that layer of the atmosphere which has a maximum concentration of ions that are created by electromagnetic radiation coming onto the surface of the earth. As weather conditions change on the earth from time to time, the ionospheric layer also undergoes changes. So statement 2 is correct. As ionospheric layer undergoes changes, the skywave signals are less stable than the ground wave signals. Three perfect gases at absolute temperatures T1, T2 and T3 are mixed. The masses of molecules are M1, M2, M3 respectively, and the number of molecules are N1, N2 and N3. Assuming no loss of energy, the final temperature of the mixture is energy of the gases before mixing them E equal to N1 K T1 plus N2 K T2 plus N3 K T3. That is, we can take K common, that is Boltzmann's constant. We get N1 T1 plus N2 T2 plus N3 T3. The energy of the mixture of the gases is E final equal to N1 plus N2 plus N3 of Kt. Here again Boltzmann's constant is K and T is absolute temperature. Now since we are asked to calculate the common temperature, we can equate both the energies, as the given condition is that there is no loss of energy during the process. From there we obtain capital T equal to N1 T1 plus N2 T2 plus N3 T3 by N1 plus N2 plus N3. A pulley of radius 2 meter is rotated about its axis by a force F equal to 20T minus 5T square Newton applied tangentially. If the moment of inertia of the pulley is 10 kg meter square, the number of rotations made by the pulley before its direction gets reversed is. Let us start the problem with finding the torque acting on the pulley, tau equal to R into F perpendicular, that is 2 into 20T minus 5T square, that comes out to be 40T minus 10T square. You can see tau is dependent on time. Now tau also can be written as I alpha, where I is moment of inertia and alpha is angular acceleration. From there we get alpha equal to 4T minus T square. As it is variable, we can find angular velocity by integration method. Alpha equal to d omega by dt, that is equal to 4T minus T square. Upon rearranging the terms, we get d omega equal to 4T minus T square into dt. Applying integration on both sides, and we get omega equal to 4T square by 2 minus T cube by 3. As we need to calculate the number of rotations made by the pulley before its direction is reversed. So for the reversal of direction, the pulley has to come to rest first. So put omega equal to 0, we get T equal to 6 seconds. Now, as the angular velocity is also a variable, we can find the displacement, that is angular displacement theta, by integration method again. We can write omega equal to 4T square by 2 minus T cube by 3. Omega is d theta by dt. So d theta by dt equal to 4T square 2 minus T cube by 3. Rearrange the terms. D theta equal to 2T square minus T cube by 3 into dt. Upon integrating both sides, we have theta equal to 2T cube by 3 minus T power 4 by 12. So that implies theta equal to 36 radians when you put T equal to 6 seconds. From there the number of rotations N equal to 36 by 2 pi, which gives us the value of N to be greater than 3 and less than 6. A resistor R and a 2 microfarad capacitor in series are connected through a switch to 200 volts direct supply. Across the capacitor is a neon bulb that lights up at 120 volt. Calculate the value of R that makes the bulb to light up. After 5 seconds, the switch has been closed. Voltage required for the neon bulb is V equal to 120 volt. The time lag required in the circuit is 5 seconds. So voltage across the capacitor V equal to V times 1 minus e power minus t by RC. It is 120 equal to 200 of 1 minus e power minus 5 by 2 into 10 power minus 6 into R. That comes out to be 0.6 equal to 1 minus e power minus 5 by 2 into 10 power minus 6 into R upon simplification. We get capital R equal to 5 by 2 into 10 power minus 6 into 0.92, which comes out to be 2.7 into 10 power 6 ohm. A Carnot engine operating between temperatures T1 and T2 has efficiency 1 by 6. When T2 is lowered by 62 Kelvin, its efficiency increases to 1 by 3. Then T1 and T2 respectively are. Efficiency of Carnot engine eta equal to 1 minus T2 by T1. Now the initial efficiency is 1 by 6. So I can write 1 by 6 equal to 1 minus T2 by T1. Now the final efficiency is 1 by 3, that is obtained by decreasing the sink temperature by 62 Kelvin. So I can write 1 by 3 equal to 1 minus T2 minus 62 by T1. Upon simplification, we get T1 equal to 372 Kelvin. By substituting the value of T1 in the first equation, we get T2 equal to 310 Kelvin. If a wire is stretched to make it 0.1% longer, its resistance will become. The resistance of a wire is given by R equal to rho L by A. Multiply and divide with the length, it becomes rho L square by V. We should do this so that we can maintain the other variables constant as we take the relation between resistance and length. So here V is volume of the conductor, A is area of cross section, L is length of the conductor. Now the formula becomes R equal to rho L square by V. Rho and V are constants, so we can say R is proportional to L square. Now applying log on both sides and differentiating, we have log R equal to log K plus 2 log L. Differentiation dr by R equal to 0 plus 2 dl by L. The differential of a constant is 0. From there, we get fractional change in resistance. Multiply with 100, we get a percentage change in resistance. That comes out to be 0.2%. A thin air film is formed by putting the convex surface of a plane convex lens over a plane glass plate. With monochromatic light, this film gives an interference pattern due to light reflected from the top surface and bottom surface of the air film. Now, statement 1. When light reflects from the air glass interface, the reflected wave suffers a phase change of pi. Statement 2. The center of interference pattern is dark. This question is regarding Newton's rings experiment that demonstrates interference of light through thin films. Here a thin film of air is found between plane glass plate and plano convex lens as shown in the next slide. A car is fitted with a convex side view mirror of focal length 20 cm. A second car 2.8 meter behind the first car is overtaking the first car at a relative speed of 15 meter per second. The speed of the image of the second car as seen in the mirror of the first one will be. Let us apply mirror formula 1 by V plus 1 by U equal to 1 by F. Since it is a convex mirror, U is negative, V and F are positive as we apply sign convention. So from the formula we get 1 by V minus 1 by 2.8 equal to 1 by 0.2. From there we get V equal to 2t by 15 centimeter. Now since we are interested in speeds, apply differentiation on both sides of the mirror formula. We get minus 1 by V square dV by dt minus 1 by U square du by dt equal to 0. Focal length is constant, so its differentiation is 0. From there we get dV by dt equal to minus V square by U square du by dt. Substitute the values of V and U. We get the speed of the image to be 1 by 15 meter per second. Energy required for an electron excitation in lithium from first to the third Bohr orbit is. Energy of the electron in Bohr's orbit is given by En equal to minus 13.6 by n square into z square electron volt, where z is the atomic number, n is the number of the orbit. Since the electron has to go from first orbit to third orbit, energy of the electron in the first orbit E1 equal to minus 13.6 by 1 square into 3 square. Lithium's atomic number is 3. That comes out to be 122.4 electron volt. Now the energy of the electron in the third orbit will be minus 13.6 by 3 square into 3 square. That comes out to be minus 13.6 electron volt. Energy required for the electron excitation delta E equal to E2 minus E1. That comes out to be 108.8 electron volt. The electrostatic potential inside a charged spherical ball is given by phi equal to AR square plus B, where R is the distance from the center, A and B are constants. The charge density inside the ball is. The electric potential inside the sphere, phi equal to AR square plus B. From here let us find electric field intensity by applying the relation E equal to minus d phi by dr. From there we get electric field equal to minus 2AR. Now apply Gauss theorem. It is integral E bar dot dA bar equal to 1 by epsilon naught Q in. So electric field already we found, that is minus 2AR. The area of the spherical shell or the Gaussian surface is 4 pi r square equal to 1 by epsilon naught. Q in I can write as rho into dV, where rho is the charge density and dV is the volume of the Gaussian surface. Then we can substitute the values of dV, that is 4/3 pi r cube, and upon simplification we get the charge density rho equal to minus 6A epsilon naught. A water fountain on the ground sprinkles water all around it. If the speed of water coming out of the fountain is V, the total area around the fountain that gets wet is. Range of water from the fountain R equal to V square sine 2 theta by G. For maximum range, that is radius of the circle, R max equal to V square by G, since theta is 45. Now area is pi r square, so it comes out to be pi V power 4 by G square. 100 gram water is heated from 30 degrees centigrade to 50 degrees centigrade. Ignoring the slight expansion of water, the change in its internal energy is. Specific heat of water is 4148 joule per kg Kelvin. Now the heat required to take the temperature of water from 30 degrees centigrade to 50 degrees centigrade is given by dq equal to ms delta T. Mass is 0.1 kg, specific heat is 4148, the temperature difference being 20. That comes out to be 8296 joule. Since the expansion of water is neglected, the work done in the process is 0. Applying first law of thermodynamics, dq equal to du plus dw, we get du equal to approximately 8.4 kilojoule. The half-life of a radioactive substance is 20 minutes. The approximate time interval T2 minus T1 between the time T2 when 2/3 of it has decayed and time T1 when 1/3 of it has decayed is. Fraction of radioactive substance remaining is given by m by m naught equal to 1 by 2 whole power small t by capital T, where small t is the time of concentration and capital T is the half-life of the radioactive material. Now time taken for 1/3 of substance to decay, that is 2/3 to remain, 2 by 3 equal to 1 by 2 whole power T1 by 20. Time taken for 2/3 of the substance to decay, that is 1/3 to remain, is 1 by 2 whole power T2 by 20. Now taking the ratio of the two expressions, we get 1 by 2 equal to 1 by 2 power T2 minus T1 by 20, that is T2 minus T1 by 20 equal to 1. So the time interval T2 minus T1 equal to 20 minutes. Statement 1. A metallic surface is irradiated by monochromatic light of frequency nu, that is greater than nu naught. The maximum kinetic energy and stopping potential are Kmax and V naught. If the frequency of incident radiation is doubled, both Kmax and V naught are also doubled. Statement 2. Kmax and V naught of the photoelectrons emitted from the surface are linearly dependent on the frequency of incident light. Let us see Einstein's photoelectric equation E equal to 5 plus Kmax, that also can be written as EV naught. In terms of frequency, h nu equal to h nu naught plus Kmax. From the above equation, we can see as the frequency of incident radiation is doubled, the maximum kinetic energy and hence the stopping potential will be more than doubled. Coming to statement 2, as seen from the equation, we find Kmax, that is V naught, are related to incident frequency in straight line equation, that is also known as linear relation. So the correct option is 3.